So what we've come to recognize is that there's different gases in the atmosphere that will absorb infrared radiation. Carbon dioxide is one of them we talk a lot about. So now the question is, how does carbon dioxide get into the atmosphere? All right, so is it just stuff that we're doing, or is it just naturally get there? And we'd like to kind of back up and take a picture or a look at how carbon gets into the atmosphere. So there's something that you may have heard of before called the carbon cycle, and this is how we describe how carbon, the element carbon, cycles in and out of the atmosphere and in and out of living and dead systems. Okay, so let's take a look at the carbon cycle real quick here. This particular picture is from your book. It's actually very complicated. This is a picture of the carbon cycle. It's a simplified view of the carbon cycle. And so what you see here is atmospheric carbon dioxide. When carbon is in the atmosphere, it's largely in the form of carbon dioxide. So the carbon is inside the molecule, or part of the molecule carbon dioxide. All right, so we need to distinguish, when we talk about the carbon cycle, the first thing you have to distinguish is between carbon, just elemental carbon, and carbon dioxide. All right, so when people talk about the carbon cycle, they're talking about elemental carbon and how elemental carbon cycles in and out of the, I'm using the wrong pen, dioxide cycles, in and out and around through living and non-living systems. All right, so when it's in the atmosphere, right here we say there's 750 GT. What does that stand for? GT stands for gigatons. There's 750 gigatons of carbon in the atmosphere, and that is mostly in the form of carbon dioxide, but we're talking about this mass here. Gigatons is the mass of carbon. All right, so what is a gigaton? A gigaton is the same thing as 1 times 10 to the 9th metric tons, which is a billion metric tons. Okay, what is a metric ton? A metric ton is about 970 kilograms or so. That's what a metric ton is. And a billion metric tons is sort of hard to imagine, especially when we think of the atmosphere. We think of the atmosphere as, not really weighing very much, and carbon dioxide is a gas. But as it turns out, 750 gigatons, and a gigaton is a billion metric tons. A GT stands for a billion metric tons. That's the same as the mass of 3,747 planes. Okay, 3,747 planes, that's a lot of mass. All right, but you got to think about it. You think about the air around you in your little space where you exist right now, but we're talking about throughout the whole world, the atmosphere surrounding the entire world. All right, let's see here. What else is on this picture that we need to take down? The arrows going down here are showing that how the carbon dioxide cycles back down. And in this case, it's cycling back down into the water. But all of these cycles, this is either the carbon going into the water or into the ground, or out of, in this case, a smokestack, or out of the ground, out of trees, out of the water. So it's carbon dioxide cycling in and out and around. And, when carbon dioxide, and to complicate things, these cycles occur at varying rates. Some things are happening very, very, very slowly over millions and millions of years, such as the carbon getting all the way down to the soil, through the rock, into fossil fuels over millions of years, and then carbon even in and out of the oceans, dissolving as carbonates or back out as carbon dioxide over hundreds of years. Okay, so the cycles, they're not all the same rate. That's another complicating factor. Also, we can think about the carbon in the atmosphere mostly in the form of carbon dioxide, but when the carbon goes into trees, trees undergo photosynthesis, and grass and phytoplankton and all these other kind of plants undergo photosynthesis, in which the carbon dioxide is what we call fixed, and it becomes a hydrocarbon in the form of sugars and whatnot, okay? So, so in this case, it's no longer carbon dioxide, but we're just tracking the carbon. So the oxygen's peeled off and we're left with the carbon in the trees, in the grass. Carbonates, they could dissolve in water, precipitate out with calcium, and make calcium carbonate, which is another way that we can trap carbon in the form of carbonates. And that's the same thing as limestone. Okay, so we see that it's rather complicated. All the while we're tracking the carbon, and fossil fuels, you know, sometimes fossil fuels are just carbons and sometimes they're hydrocarbons, like natural gas is CH4. Octane, you know, the main component of gasoline is CH818. So we're tracking the carbon in all these different forms, including in the atmosphere is carbon dioxide. So when we talk about carbon cycle, we're talking about, in particular, the carbon. And the carbon is cycled back from living things to non-living things, back to the gas in these cycles. Okay, so that's the carbon cycle, that when we talk about the carbon cycle. And a little bit later on, we're going to want to try to relate, you know, when we say there's 750 gigatons of carbon in the atmosphere, how much carbon dioxide does that really mean? All right, so this is, we're just looking at the carbon. We'd really like to know how much carbon dioxide there is, because we know how much infrared energy the carbon dioxide absorbs, and so then scientists can make relations between the concentration of carbon dioxide in the atmosphere and the amount of infrared radiation they expect to be absorbed.